Okay, guys. This is a bit of a lengthy note on the cycling of matter in ecosystems. We'll talk about the water cycle, the nitrogen cycle, etc. Get down what you can into your notebooks, and if this takes longer, and this is a lengthy one, so just do the best you can. If you have to take a break partway through and then get back at it, that's not a big deal. Okay. So, cycles. What is a cycle? What does the word cycle mean? A cycle, and you don't have to write that down. Those are things that we would discuss if I had you face to face. So a cycle is a pattern of change that's continuous. That means it goes round and round. Day and night, seasons, birthdays, life cycles, those are cycles. All right. And here you see a rock cycle that you don't need to know for this particular course. We're not doing this particular worksheet right now. So let's start with the water cycle. The water cycle is a continuous cycle that has no end, no beginning. Water molecules are transported from the ocean to the air, back to the land, and then back to the ocean. And you can kind of see that process happening here. Groundwater, surface runoff, rivers, lakes, they all drain into the ocean, and then they evaporate from the ocean. They condense as clouds. Precipitation falls on the land, and then it drains back. That is essentially the water cycle right there. There's not a whole lot more to it. Continuing with the water cycle, water continuously cycles through aquatic and terrestrial ecosystems by the means of three processes: evaporation, condensation, and precipitation. Evaporation is the process by which liquid water is turned into gases. Condensation is where it goes from gas back to liquid water, and precipitation is where that liquid water falls back down to the earth. Precipitation is a fancy way of saying rain. Water is an essential compound to life on Earth, for sure, and they think it's essential for life anywhere. That's why they hunt for planets that have liquid water on them. 60 to 70% of the human body is water. The brain itself is about 70% water. The lungs are nearly 90% water, and humans can only live 3 to 7 days without water. 7 would really be pushing it. You can live without food a lot longer than you can, not a lot longer, but longer than you can without water. Down here it says label the water cycle diagram. You can come back to this PowerPoint, but I also have pages from the textbook attached to this post where you can label the water cycle diagram. And you can draw this if you'd like. I have a handout that you can print out and fill it in. It's going to be up to you guys, okay? Now, how about nutrient cycles? Remember, a decomposer, and this is from before, is a consumer that breaks down wastes. And wastes can be any type of waste, can even be dead things, dead organism, feces, urine. Anything that breaks that stuff down is called a decomposer. Insects that live in the soil can be decomposers. Earthworms are decomposers. Mold, mushrooms are decomposers. Certain types of bacteria can also be decomposers. Actually, lots of bacteria are considered to be decomposers. When decomposers break down these wastes, they release chemical substances that are key for life, like carbon, nitrogen, iron, and phosphorus. Then these enter into the soil, the water, and the air to be used by our producers, plants. Pause this video whenever you need to catch up, which will probably be often because I'm going fairly quickly. Living things use these nutrient substances to grow, build their bodies, and help carry out life functions. And this cycle of continual use and reuse is essential for life. And again, there's a nutrient cycle diagram for you to label as well. You can look at this one right here, but I would say this one's a little more complicated than what we need. Basically, you're just looking at what do the decomposers do in these nutrient cycles to get things back going again. How about the carbon cycle? Carbon is the most common element in living things, and that's because it can arrange itself in the greatest number of ways in chemical compounds. For example, like CO2, 1 carbon, 2 oxygen. Plants take in CO2 for photosynthesis that organisms give off through cellular respiration. That's from a previous lesson. Decomposition of organic matter and the burning of trees give off CO2. Carbon in fossil fuels is released when burned. So those are all ways of getting carbon into the atmosphere. Once it's in the atmosphere, the carbon dioxide is used through photosynthesis by these producers. When the organic things die, then that carbon is broken down by decomposers, put into the atmosphere, and put into the ground. And then it's reused again, used by the organisms, put back into the atmosphere, and it goes around and around and around and around. Now, I don't want you to get the idea that burning fossil fuels and that is good, because the plants need the carbon dioxide. They've got just the right amount of carbon dioxide already. We don't need to increase the amount of carbon dioxide. While some plants actually might benefit from that, most living things would not. How about the nitrogen cycle? Nitrogen makes up 78% of the Earth's atmosphere. That's from a previous lesson, and is needed by all living things. Some bacteria enable nitrogen 2 gas, N2 gas, to be converted into nitrates. That's a type of compound that has nitrogen in it, a form of nitrogen which is used by plants and animals. Lightning can also take nitrogen out of the atmosphere and put it into the ground. Oh, and that's the end of our cycles there. And we've got a picture here of the nitrogen cycle. Nitrogen fixation is the process by taking N2 gas. Well, I want to go back there. I want to open this back up. Sorry about that. I just want to write on this a little bit more. And it doesn't want to let me. Oh, there we go. So it takes the N2 gas, and then lightning and also bacteria can do this nitrogen fixation, which means putting it into the ground and making nitrates. So examples of nitrates are like this NH4, NH3, NO2, NO3. Those are compounds that that can be used by living things as building blocks to make themselves. Denitrification is where we actually use those and put them into the living things, and then they go back around and they go back around and they go back around. And that is the very definition of a cycle. So now you have all you need to know. If you take senior biology, you'll get into these cycles probably a little deeper. If you take biology in college or university, you'll get into them deeper. As far as I'm concerned, you just need these basic facts about the nitrogen cycle, the carbon cycle, which are both examples of nutrients. And the first one we looked at was the water cycle. So I do have, I wouldn't say a lengthy assignment, but it's like 2 pages because it's got diagrams and stuff in it to label. So I'm going to discard my writing here and open it up for you to see. So it's not going to take you a long time to do, but it looks kind of intimidating in a way because I want to open that up. Let's go into the edit here. Move me over here. There's that PowerPoint we just had a look at, and then the cycling of matter assignment is here. It does say to look in the textbook, for example, on page 29 and on page 31, and I have attached those pages. And then you have to answer these questions here. What path do they follow and stuff like that. So I am not marking you on artistic ability. The easiest way by far to do this little assignment would be to print these pages off if you have access to a printer. If you don't have access to a printer, then just do the very best you can to draw these things out. And you could even draw these like these, or you can see some of the parts were hand drawn once upon a time by me. And this one here is a photocopy. But if you even want to take the pictures from the pages in the textbook, which are 29 and 31, this is the one that I got from there. So I just want you to be able to represent the water cycle with that. So it's pretty easy. You got land, you got oceans, you got sun, you got clouds, and just have the arrows used to show you that water cycle. And then on page 31, I did take this one and just kind of went over it with pencil because it was hard to copy this one. But again, I just want you to look at this general nutrient cycle, the role of the decomposers, how it gets back into the plants and back to your consumers, and then back to the decomposers. All right. So that's what that assignment's asking for. It's going to be a little bit awkward for you guys to do that one because it's really designed to be done on this handout here. So you guys are going to have to draw out those cycles if you can't print off the sheets. If you can print off the sheets, then fantastic. Do it on that. Send me a picture of this assignment, and that'll be that. And then also you can answer these questions here. And that'll be that for that lesson. Obviously, we're going to meet back at 9:55. Now, there was 2 notes to do in this first block today that I tried to squeeze in. So if one of them bleeds over into block 2, it's not a big deal. I'll make sure there's time at some point today for you guys to get caught up if you need to catch up on this note, if you need to do one of those assignments, you weren't able to get them done, whatever it is you need to do. I'm not trying to overwhelm you with an amount of work here. All right, that's all for now. I'll stay on Google Meet in case you guys have questions for me. Or if you don't want to talk to me face-to-face on Google Meet, you can email me and I'll keep my email window open so I can answer your questions that way. If you're wanting me to answer questions based on something that you're looking at, it helps when you email me to send a picture of what you're working on, especially if you're asking, like, does this water cycle look right to you? Then I need a picture with that in order to tell you one way or the other. All right, that's all for now.